Welcome to Algebra 1. Our first unit is one-variable linear equations and inequalities. Our first lesson is on order of operations and combining like terms. So this is review material for most of you, if not all of you, but we felt like moving forward it would be a good idea to review some of this. Order of operations is simplifying an expression using a specific order. So specific order is very important. So whenever you see an expression with a bunch of numbers and operations like addition, subtraction, multiplication, division, exponents, and all of those things, what do you do first? So what you want to look for first is parentheses. And by parentheses, I actually mean any grouping symbol. So yes, we have parentheses, but we also have box brackets, we have braces, we have absolute value symbols, we even have division symbols which separate the top as a group from the bottom. So you can do those independently, the top from the bottom. After we do everything inside parentheses that we can, or any grouping symbol, we move on to exponents. All right, so exponents are next. So once you've finished with the parentheses, you work and calculate the exponents. Once they're done, then you look for the multiplication and division. Multiplication and division are not in any specific order. It's actually in order as you read it. So if you're reading from left to right and division is first, you will work the division first. Okay, and if multiplication is at the end, that's okay. You do that next. After your multiplication and division, you're going to work on addition and subtraction. Again, they are not in any specific order. It all depends on what order they are from left to right as you read it. Okay, so knowing this, if you take a look at everything I have in red, it reads PEMDAS. So we know now what it stands for, but something to help you remember might be, please excuse my dear Aunt Sally. If there's something else from your previous math classes that helped you remember order of operations, you feel free to use that. You don't have to memorize this. This is just a tool if you didn't have one. All right, let's look at some examples. You'll notice in all of the notes that we have plenty of examples. I give you too many examples so that I can leave some for the video in the notes, some for maybe a warm-up or an activity, or some will be left for tutorials. So I'm not going to do every single one of these in the note-taking process. I'm going to leave some for later. All right, let's take a look at number 1. 2 to the third power, that's an exponent, but I look later and I see 6 plus 4 in parentheses. You want to do the parentheses first. So 2 to the third power stays the same for now. Minus 5 times 6 plus 4 is 10. And then divide by 2. All right, I'm done with what's inside parentheses. I can't do any more. So then I look 2 to the third power is 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. So now I know 2 to the third power is 8 minus 5 times 10 divided by 2. Okay, now I'm done with the exponents, so let's take a look at the multiplication and division. So multiplication comes first from left to right, so I do that first. So I have 8, negative 5 times 10 is negative 50. And then I have divided by 2. So 8, and then I have the division of negative 50 divided by 2, which is negative 25. And now I'm ready for the final step, which is subtraction. 8 minus 25 is negative 17. All right, the question always is, can you do this on the calculator? All right, so let me open up a new one here. Okay, and there we have it. So 2 to the third power minus 5, parentheses 6 plus 4 divided by 2 is negative 17. So I use the calculator as a double check if it's easy enough to plug in. You must show your work on your note, on your assignment, so please keep that aware of that. But you can always double check on the calculator. Just be very certain you have your parentheses correct, because if you have parentheses inside of brackets, then you need 2 sets of parentheses, and so on. Okay. Let's move on to number 2. All right, we have 86 minus. So in box brackets, that's where I look first. Inside the box brackets, I have parentheses. So I have 4 minus 9, which is negative 5. And I'm squaring that and multiplying by 3. Still not done inside the box brackets, so I'm going to continue. 86 minus. There's an exponent there, so I need to do that first. So negative 5 times negative 5 is a positive 25 times 3. All right, I still have to work inside those brackets, so I have 86 minus 25 times 3 is 75. And 86 minus 75 is 11. And I'm done. I can double check on the calculator. And by the way, if you get something different on the calculator, it may be that you've incorrectly inputted into the calculator. So if you need some help, just let me know. All right, let's move on to number 9. Okay, a little bit more things happening here all at once, so let's take a look. I'm going to leave the 3 squared alone for now and the minus 3 because I want to work with what's inside the brackets. Inside the brackets I have parentheses, so I have 5 squared, which I know is 25, minus 9 divided by 2, still working inside. 25 minus 9 is 16. Okay, got one more step in here. 16 divided by 2 is 8. Okay, then I have 3 squared. Okay, I've done everything inside the box brackets I can, so I look for the exponents. So I have 9 minus 3 times 8. 3 times 8 is next. It's actually negative 3 times 8, so it's going to be 9 minus 24. And 9 minus 24 is negative 15, and that's going to be my final answer. All right, let's get a division. So let's take a look at number 10. We're going to separate the top from the bottom. So for number 10, I have 3 minus 13 inside parentheses, which is negative 10. That's got to be done first before I square it. Now, on the bottom, I can see what I can do first there because it's separated from the top. So there's no parentheses, but there is an exponent. 4 squared is 16 minus 5 times 2. All right, back to the top. We have negative 10 squared is 100, positive 100, plus 14. On the bottom, we have 16. And then negative 5 times 2 is a negative 10. Let's continue. We're just going to add on the top 114. 16 minus 10 is 6. 114 divided by 6 on your calculator is 19, and you're done. Let's try one more hard one on the bottom of the page. Let's take a look at number 16. All right, for number 16, let's look at box brackets on top first. So we have 12 times 30 minus. So inside those parentheses, I have 9 plus, and then 4 squared is 16. Okay, on the bottom, I have 10 minus a negative 6. Double negative is a positive, so the only thing I'm going to change here right now is to make that double negative a positive, and then I go back to the top. We've got 12, and then in box brackets, we have 30 minus 9 plus 16 is 25. And then on the bottom, we have 10 plus 6, which is 16. Back to the top. 30 minus 25 is 5. All over 16. So 12 times 5 is 60. Divided by 16. Now that's going to be a fraction. So how do you figure out? I don't want you to stress over fractions. I want you to be able to have a tool to help you easily get through these fractions. Okay, so let's take a look. Got a new calculator here. So if I type in 60 divided by 16, it's going to give me a decimal, and it will always do that. So you want, in order to get it back to a fraction, you hit the math button and then enter, enter. And it reduces that fraction, 60 over 16, to 15 over 4, and now you have a reduced fraction. All right, let's move on to combining like terms. All right, here we have a long expression, but a bunch of the things are like terms. Variable terms are terms that have a letter next to it. So if you've got variable terms, you have terms like 7x, negative 5x, and 4x. The coefficients are the numbers that are attached to the variable. So the coefficients here would be 7, negative 5, and 4. The constant terms are the terms without a variable, so like 3, 8, and negative 1. Those are called constant terms. So you have variable terms and constant terms. All right, how can we simplify this expression by combining like terms? So you take all the things that are alike. For example, 7x, negative 5x, and positive 4x are like terms. So you simply take the coefficients and add them or subtract them appropriately. So 7 minus 5 is 2, and 2 plus 4 is 6, so we end up with 6x's. The constant terms are 3, positive 8, negative 1. So you have 3 plus 8, which is 11, and 11 minus 1 is 10. And now you've combined like terms and simplified your expression. Let's try some more. All right, let's take a look at number 1. 3x plus 6x. So you add 3 and 6 to get 9x. Number 2, 9a minus 10a. 9 minus 10 is a negative 1. And you simply, all you have to do is write the negative and the a. You do not have to write the negative 1. How about number 4? So we've got negative 6x, which is by itself. There's no like terms there. Then you have a 9 plus a 5. And that's going to give you a plus 14. So we've combined what we could, which is just the constant terms. All right, let's take a look at number 7. Those are two terms that are like terms. So you've got an x squared and an x squared. So the exponent has to be exactly the same. The coefficient can be different, the number out in front. All right, so if you have an x squared term here and an x squared term here, then you have you can simply add those together and get 12x squared. All right, let's try some harder ones here. Okay, number 10. Here you have all cube terms, x to the third power. Those are all like terms. So it's going to be 8x to the third minus 7x to the third is 1x to the third. And 1x to the third plus 16x to the third is 17x to the third. Okay, what about number 11? You have a squared b to the first, a squared b to the first. Those are like terms because they have the exact same variable and exponent. They have to be the same. So what we're going to do is combine the negative 4a squared b plus 10. So negative 4 plus 10 is 6a squared b. And then the constant term is by itself, so we can just add 7. All right, let's try one more. We're going to find the perimeter. So you have to think about, how do you find the perimeter of any figure? You add up all the sides. So if this is a rectangle and the top is 3y minus 5, then the bottom is also 3y minus 5. If the left side is y plus 2, then the right side is the same, y plus 2. Okay, so we're going to add up all of the y's together. So we have 3 plus 1 is 4, plus 3 is 7, plus 1 is 8y. Then you add all the constant terms together. So you have negative 5 plus 2 is negative 3. Negative 3 minus 8 is a negative, or excuse me, minus 5 is a negative 8. Plus 2 is a negative 6. And that is your final combined expression. All right, so I hope you've had enough examples, a little preview of what you're about to see in class when we meet next.